Okay, so the next question we're going to look at is going to be question 12, where we're going to find the unit tangent vector, the unit normal vector, and finally, the curvature function. And we're going to do it for the space curve 3 square root of 2t, e to the 3t, and e to the negative 3t. Okay, so we'll begin by trying to find the unit tangent. So that starts by differentiating. And that guy gets you 3 root 2. This one gets you 3e to the 3, and this gives you negative 3e to the negative 3t. Pretty straightforward. Magnitude of that vector is going to be the square root of each of those components squared. And hopefully you can make this turn into something nice. Well, that's 9 and that's 2, so you get 18. That's 9e to the 6t, and this is 9e to the negative 6t. So if I rearrange these guys in order, and at the same time pull out 9 as a common factor, I get e to the 6t, I get plus 2, and I get e to the negative 6t. And I recognize that as a perfect square. And the perfect square is the square root of that guy, e to the 3t, plus, because of this, e to the negative 3t squared. And that comes out nicely as 3, and that comes out as e to the 3t plus e to the negative 3t. Which means we can now do our unit tangent vector. 1 over the magnitude times that guy. So what's that going to be? It's going to be 1 over 3 e to the 3t plus e to the negative 3t times this guy, finally this guy. We put that together, we can cancel some 3's while we're at it, and we get 3 root t over this guy, 3e to the 3t over the same guy, and lastly, negative 3e to the negative 3t over this guy. Not a very pretty answer, but that's what it is. So to move on to B, to find the unit normal at t, we first have to find the derivative of the unit tangent vector. Now that unit tangent vector is really ugly, and it's going to take quite a long time to do that. So essentially what I'm going to do instead is just take each one and differentiate it. This one here would be a quotient rule. Actually, all of them would be quotient rules, and they'd all be really ugly. But once you're finished, you get, I believe, these expressions. And so what I'm now going to do is find the magnitude of that. It's going to be the square root of that one, and lastly, this one. Foil this guy out. What do you get? You get 1 minus 12 e to the 12t. And this guy, you get 2 e to the 6t. This guy, you get 2 e to the negative 6t. And that's the end of that question. Okay. Well, the next stage is to get the unit normal vector. And the unit normal vector is going to involve us finding the derivative of this guy and then the magnitude of this guy. Well, we already know what the unit tangent looks like, which is really ugly. So you can imagine that to calculate this, we're going to have to do quotient rule 3 times. Then we're going to have to do some ugly square roots to get the term here. And when you're finished and you've done some simplification, the answer ends up looking like this. And the unit tangent vector, this guy here, ends up looking like that. So when you do the curvature, and the curvature, as we know, is the magnitude of the unit tangent vector divided by the magnitude of the first derivative. We get square root 2, 3, e to the negative 3t divided by e to the 6t plus 1. And that would be the end of that particular question. And we will now move on to our next question.